Right, here's our third example, finding the area of a segment. Each example is getting just a little bit trickier than the last one, so let's just keep that in mind that this one might be a little bit more involved. First though, let's just take a look at our circle and figure out what we know about it. We can see that the radius is 12, which means that this is going to be a 12 over here also. The measure of our arc is 120 degrees, which makes the central angle 120 degrees also. Now, looking ahead, we know that we're going to have to end up finding the area of this triangle right here. It's not an equilateral triangle because this is 120 degrees versus the 60 degrees. So when we get to step 2, just know that it's going to be a little bit more involved to find the area of that triangle, but I'll just save that for step 2. All right, finding the area of a segment, starting off with step 1. First thing you find is the area of the whole sector. So you take your, I'll write it out, m over 360 times pi r squared. So the measure of our arc is 120 degrees over 360 times pi times the radius, which is 12 squared. All right, so 120 over 360, I can cross off the zeros. 12 over 36 reduces to 1 over 3. Pi times 12 squared is 144. And then 1/3 times 144 is going to give us 48 pi. So there's the area of the sector. We're going to need that with our last step. Now let's figure out how to find the area of the triangle. This is going to be just a little bit more involved, so get excited for that. So step 2 is to find the area of the triangle. I'm going to go ahead and redraw the triangle over here so we can see what we're looking at. We know that this is 12, this is 12. Remember, area of a triangle is equal to 1/2 base times height. So if we can figure out the base and the height, then we've got this, right? All right. So what we're going to be able to do here is draw in the height. That is giving you a 90-degree angle. And it's also cutting our big triangle into 2 small triangles. So if you remember, this is 120 degrees. We just cut that in half, giving us 60 degrees inside each of those smaller triangles. So now I'm going to just look at one of the small triangles. We know that this is 60, this is 90, which means that must be 30. So we're looking at a 30, 60, 90 triangle. If you remember how we label those, now we just always want to keep this in the back of our head. A 30, 60, 90 triangle is your special right triangle. Across from the 30 is the x. Your hypotenuse is 2x. And across from the 60 is x root 3. So what do we know? We're going to put in, we know that this is a 12, which is the hypotenuse of that triangle. You put an equal sign in between, and we're going to solve for x. So 12 equals 2x. Divide both sides by 2, and x equals 6. So that gives us a 6 right here. That is the height of our triangle. And then the other side, this is going to be a 6 square root of 3. That's part of the base. So if I kind of bring this back up here to where it is, that's this 6 square root of 3. Well, this is going to be a 6 square root of 3. So if we combine those, add those together, our base is a 12 square root of 3. All right, you guys still with me on this one? We are getting close to the end. So our area is equal to 1/2 times our base, which is 12 square root of 3, times our height, which is 6. So we're going to multiply the 1/2 and the 12 first. That gives us a 6 square root of 3 times this 6. You can multiply the 6's together, giving you 36 square root of 3. So that is the area of the triangle. All right, this is looking good, isn't it? Look at all that work. Now we are ready for step 3 that says to take the area of the sector and subtract out the area of the triangle. Remember, it's step 1 minus step 2. So the area of our sector was 48 pi minus the area of our triangle is 36 square roots of 3. Those are not like terms, so we're going to leave our answer like that. We just need our units squared. So we get weird looking answers, but that's okay. That's an exact value, and it is correct.